Hey everyone, I'm Alexander Ross, a Mechatronics Engineering student at Macquarie University, and over the past few months I've been interning at Rapid Analysis, where I've had the opportunity to dive deep into hardware design and embedded systems. Today I'm really excited to share the project I've been working on during my time there, my very own custom FPGA development board, built around the ICE40 Ultra Plus from Lattice Semiconductor. Now, if you're a home project enthusiast or someone starting out with FPGAs, this might be especially interesting to you. The official eval kits for the ICE40 Ultra Plus, or even any other entry-level FPGAs, can be surprisingly expensive, and that cost can be a real barrier when you're trying to learn or build something cool. So I designed this board to offer a much more affordable way to get started. It's open, accessible, and ideal for experimenting without breaking the bank. Here's a quick look at the schematic design of the board. All of the ICE40 Ultra Plus pins are broken out into standard connectors, making prototyping super flexible, whether you're building custom logic circuits, experimenting with digital system design, or even trying out soft-core processors. Programming is simple too, just connect an FTDI programmer and you're good to go. I'll walk through that a little bit later. The board also runs off a standard 5-volt power supply, making it easy to integrate into most setups. To make development smoother, I've also included a manual reset button and a done LED to indicate when the FPGA has successfully configured, which is super handy for debugging or just confirming that your code has loaded properly. Here's a look at the PCB design. The connectors are spaced out in a way that allow for easy integration with a double breadboard setup. Here's a look at the PCB assembly. Here's some simple code I wrote to test the development board. We'll declare all the ports of the ICE40 Ultra Plus. We'll get a clock signal from the internal clock A. We'll use a simple counter to divide this clock to generate clock B. And then we'll use clock B to shift 1 through the registers representing ports on both the left and right side of the board. Programming the ICE40 Ultra Plus requires IceCube2 and Diamond programming software. Luckily, obtaining an IceCube2 license is free, as Lattice offers 3 licenses to hobbyists, enthusiasts, community educators, and startup companies. You can obtain one by emailing them. Once you've installed IceCube2, you should already have the Diamond programmer included. If you don't, you can install it as an add-on. Diamond Programmer makes flashing the FPGA super easy, as it automatically detects an FTDI connection. So it's simple, quick, and reliable. Here's a quick tutorial on how to upload code to the development board. Open up Lattice IceCube2, click New Project, and upload your code. Unfortunately, my screen record software didn't capture this part, but it should be pretty straightforward. After you've uploaded your code file, run Simplify Pro Synthesis, followed by Input P&R input files. Input pin locations and bank. I did this off camera. After that, run placer, run router, and generate bitmap. Now you need to open Diamond Programmer and click OK. Make sure you have the correct device name displayed. Click on the 3 dots under file name and click on your code, specifically the bin file. Click Program, and if the code compiled correctly, your status should be pass. Here's a demonstration of how I tested the dev board. In my case, I used an FT2232H mini module FTDI. Here's a demonstration of how I connected it.